the last class, we have discussed about what are chemical reactions. So in today's class, let us learn quickly about the chemical equations. So today's class, we will learn about what is a chemical equation and how actually we have to write the chemical equation. Okay. So let us see what are all the steps that will be there and how actually the chemical equation is written. So before actually writing the chemical equation, I just wanted you to show how a chemical reaction will take place. Okay, so let us take what is this in the test tube. So I have taken some baking soda in the test tube, which is sodium bicarbonate. So to that, if I add acetic acid like this, as you can see, so what is happening? You can see the effervescence that is coming out. Okay, a lot of gas is coming out. Entire product is getting converted into gas like this. So this is what is called as a chemical reaction. So this is how the chemical reaction takes place. Okay, so what is happening? Actually, baking soda is reacting with the acetic acid and it is producing carbon dioxide gas, which we were able to see like that. As you can remember, one of the characteristic feature of a chemical reaction is evolution of gas. So here actually carbon dioxide gas has been evolved. Okay, so that is how a chemical reaction will take place. So now let us see what are chemical equations and how actually we will be writing the chemical equations. So if you remember yesterday's activities, what we have discussed in the previous class, I told that when magnesium ribbon is burnt, okay, what will happen when magnesium ribbon is burnt? It will burn with a white dazzling light and also finally it will produce a white powder of magnesium oxide. So, okay, it produces a white powder of magnesium oxide. So this was the activity. So now for this, if you want to write a equation, for this activity, if you want to write a equation, how we will proceed? So first of all, what is an equation? Equation is a simplified form of representing the chemical reaction. So if I say that magnesium when burnt in flame, it will produce magnesium oxide, this sentence is too long. So instead of saying the chemical reaction in such a big sentence form, I can just represent it in the form of words. Like if magnesium, okay, so magnesium, if it reacts with, okay, oxygen, so we know that it is reacting with oxygen, it is producing magnesium oxide. So I can as well, okay, I can as well tell about this activity in words like this. And this is called as the word form of chemical equation. And this is called the word form of chemical equation. What it is? It is the word form of chemical equation. It is the word form of chemical equation. So I can depict my equation in this word form also. So if you have seen what are there in this equation, when I am writing an equation like this in the word form, what I am writing? I am writing what are all the two substances that are combining together and what is the substance that is obtained. So we have two parts in an equation, the left hand side of the equation and the right hand side of the equation. So we have left hand side substances we have and right hand side substances we have, and in between there is an arrow, okay, from the left hand side pointing towards the right hand side, and also you can see a plus symbol in between the substances. Now let us understand what are all this. On to the left hand side in a reaction, okay, we will be writing about, okay, or we will be depicting the substances which will be reacting together, and those are called reactants. So the substances which are present on towards the left hand side, what are they called? They are called the reactants. They are called the reactants. So those substances which will be mixing together, reacting together to produce new substance with different properties, those are called the reactants. So in a reaction on the left hand side we have what are called reactants, and then on the right hand side whatever you are writing, those are called the products. So the new substance that is formed with different chemical properties compared to the reactants, those are called the products. And the arrow indicates the formation of new substances from the reactants. Okay, and plus symbol indicates what are all the substances that are present on towards the reactant side and what are the substances that are getting formed towards the product side. Even product side also we will be putting a plus symbol whenever it is required. So that indicates actually all the products that are getting formed on towards the right hand side. So this is how in a simple way actually in the word form you can depict the equation. But instead of depicting your equation in the word form like that, you can also depict in a more easy form, which is the actual form of the chemical equation, that is by using symbols and formulas. So you know from your previous classes you have different symbols for elements and formulas for different compounds. So using those, when you write an equation, it is the actual form of the chemical equation. So you can write the same equation in the activity whatever we have seen, that is magnesium combining with the oxygen giving rise to magnesium oxide. We can write it as well like this also. You know the symbol of magnesium, that is Mg. When it combines with O2, that is oxygen, it gives rise to magnesium oxide. So like this, okay, knowing the symbols of the elements and the formula of the compound, you can write it like this. So this is how a chemical equation is depicted. So chemical equation, actually what it is a symbolic representation of a chemical reaction using symbols and formulae. The symbolic representation of the chemical reaction using the symbols of elements and formulae is what is called as chemical equation. Okay, so this is how in a easy form you can write the chemical equation. But okay, this particular type of chemical equation is called the skeletal form of chemical equation. What it is called? It is the skeletal form. It is the skeletal form of chemical equation. Why it is called skeletal form of chemical equation is, as you can see, okay, if you see the number of atoms of each element on the left hand side and right hand side. So let us see how many atoms are present. So if you see magnesium atom, okay, how many there are? Okay, there is one atom. Oxygen, if you see, there are two atoms onto the left hand side, onto the reactant side. Whereas onto the product side, towards the right hand side, we have magnesium, okay, element is 1, and oxygen, how many they are present? Oxygen is also 1. So this type of an equation is the skeletal form of chemical equation, or it is called unbalanced chemical equation. What it is called? It is called as an unbalanced chemical equation. So what is an unbalanced chemical equation? As you can see, the number of atoms on the left hand side are not equal to the number of atoms on the right hand side. So here comes the problem, because according to law of conservation of mass, according to law of conservation of mass, we know that the total mass, okay, can neither be created nor be destroyed. So the total number of atoms, okay, on the right hand side must be equal to the atoms on the left hand side. The total mass should be same. The atom number should be same on either side. So according to this law of conservation of mass, we should see that actually on both the sides, that is on the side of the reactants and onto the side of the products, the total atoms of each of the element must be same. Okay, if they are not same, then it is called unbalanced chemical equation. Because this law exists, okay, we need to balance the chemical equation. So that is the need to balance the chemical equation. That is because of law of conservation of mass. Mass can neither be created nor the total mass can neither be created nor be destroyed. So total mass of all the atoms of different elements should be same. Okay, whatever that is present onto the left hand side should be same onto the right hand side. Therefore, balancing is essential, and we need to balance the chemical equations, and therefore we proceed to learn about the balancing of chemical equations, how they are balanced. So let us quickly see how the chemical reactions are balanced. Okay. So in this case only, to make you simply understand about balancing concept, okay, here already we have seen that magnesium atoms are same on either side, but oxygen atom, okay, is one less onto the product side. So in order to balance the equation, what we can do, you have to, okay, see that oxygen number is also equal to 2. For that, what you can do, we will be multiplying oxygen with 2. So what it means that you should add a 2 in front of your, okay, products that are obtained on towards your right hand side. So when you are writing a 2 in front of magnesium oxide, okay, though oxygen has become 2, but magnesium, okay, actually was 1 only. Now, has become 2 onto the product side. So what you have to see that on the reactant side also magnesium, atoms are 2, for which what you will do, you will multiply magnesium with 2. So when you are multiplying, it implies that you write a 2 in front of magnesium also. Now see how the equation has become, whether the atoms have been balanced or not. 2 magnesium are there, yes, 2 magnesium are there. 2 oxygen are there, yes, 2 oxygen are there. So like this we can balance the equation and we can abide by the law of conservation of mass. So in order to strictly follow the law of conservation of mass, balancing is essential, and like this we can take a simple reaction and we can show the balancing part. Let us proceed further and still learn about balancing of equations in actual format, the steps and all what should be followed and other details. So moving on.